The purpose of this video is to introduce you to case-based modeling, which forms the framework within which Complexit works. It's pretty clear that the world we're living in today has gotten significantly more complex, from globalization and cyber infrastructure to global warming and global population overload to the persistent inequality and instabilities of the global economy. The world has gotten more complex. In terms of policy and politics, it's not just got more complex in terms of increasing challenges, but also to the extent to which the world has become increasingly interdependent, interconnected, and interrelated. And it's not just the world that's gotten more complex, it's the data that we use to understand it. Hence, the new revolution in data mining and big data. Not only today do social sciences have access to an increasing available data set online, but they've also got access to data that's oftentimes being collected in real time and continuously. This has presented a crisis to the social sciences, which Savage and Burroughs and others have written about. The challenge, though, then, is what do we do after the crisis? One of the key advances is the switch in orientation, which Hawking and others have stated as saying science in the 21st century is about complexity. Hence the emergence of this new field of study called the complexity sciences, which have been evolving since at least the 1940s and 50s, but more recently developing across almost the entire academy as well as scholarly inquiry. One of the key ways in which this advance has taken place is in terms of methods, from network science and geospatial modeling to big data and visual complexity, to artificial intelligence and agent-based modeling. A whole new series of methods have been developed. And these methods have a unique perspective in so much as they are case-based. In contrast to the conventional approach within probability-based statistics, which focuses on variables and aggregate behavior, case-based approaches look at cases. Think about those cases in terms of their respective profiles of factors or variables with respect to some particular outcome, and then to understand how cases group up into smaller clusters so that multiple models can be built that are more case-specific and more sensitive to the nuances of causality. One particular approach within this framework, which has become exceptionally popular, is QCA, otherwise known as Qualitative Comparative Analysis. The developer of this is Charles Ragan, and over the past 2 decades, this has grown to become a highly regarded and widely used approach to studying complexity. Within the context of QCA and a case-based approach, we have been developing a particular style which we call case-based complexity. The distinction here is the emphasis on not just studying cases, but studying cases as complex systems. And in the case of case-based modeling, focusing that orientation towards cases as complex systems, using the latest developments in computational modeling to do a case-based form of analysis. The SACS Toolkit, which you can access online through the Complexit website to get a series of readings, is the mathematical and mixed methods platform upon which Complexit is grounded. So one can think of this as case-based modeling. Within the context of that is the SACS Toolkit, which is our particular approach, and then Complexit, which is the actual software for doing the work. But again, to rehearse the steps involved in a case-based modeling approach, you have a series of cases, which can be anything. You think about those cases in terms of their respective profiles of factors. You identify some outcome, and then you seek to cluster or organize cases based on similarities in outcome and also similarities in their profiles, or what would be called their complex causality. For example, here is a QCA table. You have a variety of configurations down here based on 4 key organizational characteristics relative to some outcome. and then the number of cases associated with it. So for this first configuration, all 4 characteristics were there, and the outcome desired took place, and it was amongst 5 cases. In contrast, this only had 3 of the 4 characteristics and did not get the outcome. The question there becomes why? This is this sort of case comparative approach, looking at different forms of causality respective to some outcome and trying to get at better models that fit. Another example is using the more widely known technique of cluster analysis. Again, profiles of factors, how the particular cases, in this case the first 96, load on that profile, and then the naming of that cluster to look at that relative to some outcome. In this case was a study we were doing on allostatic load. One can even do this in the field of artificial intelligence. Both cluster analysis and artificial intelligence are part of the Complexit package, as you'll see in the other tutorials. Here, one is looking at a 2-dimensional grid, and over here a 3-dimensional grid. Again, how cases cluster around each other with respect to some outcome, and then the profile of causal factors that explain those differences. That's not, however, the end of what a case-based approach can do. While QCA and some of the more popular approaches tend to focus just on what we just talked about, one can also continue on to explore other aspects. For example, the social networks amongst the set of cases, the interactions amongst the set of cases in the case of agent-based modeling. One can even explore how cases evolve and change over time. And one can do a case-based sort of micro-simulation approach where one creates a simulated environment, tries out different types of scenarios to see how they change the trajectories of cases, which again Complexit does, or to predict future or different outcomes for cases based on known clustering of factors and cases. Which takes us to Complexit. So then you now have a basic introduction to case-based modeling. For further understanding, again, click on the PDF next to this video and it'll take you to a series of articles to read.